Okay, let's see. First, we gotta see what is this place. This is Monastery Rosano. Pretty cool place. Wow. Okay, cool. And let's look at this. Okay. This is Storm, a streaming processor. MR job 6 years ago. So what problem they have here is seems like topological one. Dependency hell and map reduced job run complex. Wanting to integrate with Apache Storm, Python is not the language used. Not ideal. Bell, 4 letters. Hmm. So basically, transform source topic to target topic. Transformer. Have checkpoint system. Checkpoint. Resume from failure. Kafka topic. Mm. Okay, so this is Salesforce connector. Let's go to the next one. Okay. Business information. Salesforce for sale target. Advertising. Oh, approach. Basically, go query and take to Salesforce. Yeah. Go and scale up. So my guess is they're gonna stream it out Kafka again. Real-time processing. Right. just use the choose transform to Salesforce format as schema. Right, so you have basically here. Wow. Nice. Data update took drop to 1 second. As high as few minutes from 16-hour noise. Okay, so probably have to retry. There's some problem with the right to Salesforce somehow. Or complex logic. target table in Salesforce. Might be join data. So join topic to publish the right data to table. Okay, nice. Good job. Sorry. Next one is do one or two more, at least two. And then we go back to re-implement one of the solution in segment tree somehow. Okay. They talk about transformer. Data pipeline. So what we really cool thing we know is basically serializer, and this serializer is very important in having a stream with message bus empower or hire a company empower to access to the data, so like sale, data science, tooling, metric. This is the power of log streaming. Probably. Intro to all these data are Basically, this is data analytics. Yeah. Our approach similar to our approach mentioned in scale. Not Salesforce. So basically, this storm here can transform topic to topic. Okay? So basically, here they do produce consumer to producer. Okay? Like one layer. So we transform it to something in S3, and then it notify another topic, I guess, and another consumer take that write to Redshift, right? Right. So you can paste. Take it, take the schema, write to S3, and then whatever. Kafka as a protocol. So basically, Kafka topic to S3 spot to write to S3. And then is the S3 for Kafka topic for the S3 rows and to write to Redshift. But pass on to S3 spall. And this would do go to Redshift spot, go to Redshift. Yeah, pretty much. Name of the topic, start and end. Hmm. 10 message, 10 row per thousand per message. 10, 1,000, 10 million. So, oh, each message is 10,000 row. So you pick salad or pizza. What? Red. Height offset, so you take the 3. What? So for number 4, you keep pasta. For number 6, you keep salad. In 5, yeah. Populate into temp table and merge. With the sugar table. What? Keeping checkpointing using so we move on to the next one. Open source. Nice. Okay, Subway. Yo. Matt Milkinson. This. Okay, so now we do small break, then let me get some water. Let me take a look at this. Maybe we can take a look at this. Let me give some backlog for read and react later. Yeah. AI isn't replacing SRE. Skilling them. Take a look maybe tomorrow. Maybe these. Maybe this is next. What else? Okay. Okay, so maybe we can look at why is this can be solved in a segment tree, right? Let me change this. Okay, so let me look at what segment tree. What is it? Similar data structure is interval tree. Okay.
They told me that I always had to be good, but being good always been problems.
Can be
It's
built
true.
in ON log n
Don't
time.
learn it, I learn it, and now I know
Oh,
I
so
don't
that
wanna
means
play
you
God.
sort
Maybe
them,
I'm
right?
crazy,
Something.
but I'm not wrong, baby, it's true. Yeah. What if I'm not good? What if I'm not good? If you never love me back. What if I'm not good? What if I'm not good? If you never love me back. What if I'm not good? What if I'm not good? If you never love me back. What if I'm not good? What if I'm not good? If you never love me back.
Okay, so you have okay.
What if I'm not good? What if I'm not good? If you never love me back. What if I'm not good? What if I'm not good? If you never love me back. What if I'm not good? What if I'm not good? If you never love me back. What if I'm not good? What if I'm not good? If you never love me back. They told me that I always had to be good.
Okay.
But being good always been problems,
Yeah.
it's true. So I learn it, and now I know I don't wanna play it, to play God. Maybe I'm crazy, but I'm not wrong, baby, it's true. Yeah.
Okay, is there any software for drawing, right? Canva. Do I have to sign up? Oh, okay. So for these, right, you have what do you have here? You have 12. Oh, let me try. What's the eraser? What? You wanna erase? Whatever. What? Any good drawing software? Start drawing. What's the eraser, bruh? Undo. Fine. So you have 12. You want to be able to given this number, and that means you need to search for this number where it is. Okay. Our previous implementation just do a binary search here. fine. But the problem seems to want to do segment 3. So what do we do? Okay. So okay, hold on. Let's put our number here first. So that, yeah, right here. Yeah, after the game yesterday, it's too late. So do now, because we have these numbers, and we somehow want to convert it to segment 3. So the first thing we know is so we have a segment from 0 to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 0 to 11. Okay. So now we split them in half, right? So 11 plus 0 divided by 2 is what? 5? This is 0, 5. Right. And so I guess this is 6 to 11. Right. 5 divided by 2 is 2, right? So 0 to 2. Oh no! Expand here, please. Man. Drawing online. This just sucks. Let's try this. Is there bigger canvas? But online drawing diagram something. Oh, maybe this would work. Ooh. So let's do this. Yeah, this is 0 to 11, right? If we do this, oh, this is nice, guys. It's auto expand. This is cool. Okay, so back to our problem. Can we increase the font here? 20. Okay, so now we have, what did we do here? 0 to 5 and 6 to 11. 0 to 5 here. And then we have 6 to 11. And we keep doing that. Right, we have 5 divided by 2 is 2, right? And this is what? 3 to 5. What? Why does the font change? Okay. So I guess this one is 11 plus 6 is 17 divided by 2 is, okay, hold on. What's that? 17 divided by 2, 8. 6 to, oh, the font here is 20. 20 here. Okay. So this is 6 to 8. Okay, And then on the right here, right, is 8 to 11. Why? Don't change my phone size. Okay. We keep divided this by 2. So 2 divided 2 is 1, right? And this is, we need to move way over here. Right. So this is 0 to 1. And this is 2 to 2, which is fine because the segment tree here said that, right? Segment tree wiki. This one can do what here? P1 P1, right? P1 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 P2, right? Whatever this is. We move right here. Move. Right. So this 8 divided by 2 is 4, right? So 3 to 4. Oh my god, running out of space here. Oh nice, it has this thing. Oh, sorry. This one. And let's move this a little bit here. We have, oh no. Okay, so we got to 2, which we end here, right? And then this has 8 divided 4, so 3 to 4. Oh no, sorry, this one is a copy. So this is 4 to 5, right? Wait, 2 to 2 is this one. Oh, this is 3 to 4, sorry. 3 to 4. Right. So move stuff to here. Okay. So then this is 5 to 5. Right. 5 to 5. We stop here, right? It's like this is fine. Right. Similar here, 14, so 67. And then 8 to 8. And this is okay. So 19 divided by 2 is 8 to 9. Right? Is it? 19 divided by 2 is 9, right? Yeah. Oh no, this is 9. Sorry guys. This is 9. That 20 divided by 2 is 10. So 9 to 10. That's fine. We want balance, right? So this is nice with the with the auto expand here. So this is 11 11, right? So what do we know here? So let's put this. It looks like a tree. Ah. Stay there, bruh. Yeah, okay. Fine. Okay. Move here. Alright. Whatever. Okay. Why the Twitch spinning? Connecting to chat. Okay, fine. Okay, so we have this. So we know that from 2 to 2, this gives us a set. How do we add the text here? Let's put this. This gives us, so 2 to 2, 0, 1, 2. So that gives us a set of 4, right? Let's do 20. Okay. Right, so 0 to 1 give us 12, 13. Okay, so let's do this. So this gives us 12, 33, right? So together this gives us oh my god. Okay, fine, let's go here. Together this gives us 12, 13, 4, right? 4. Right. So 3 to 4 this gives us 3 to 4, 0, 1, 2, 3, 4. So 56. 56, 0, 1, 2, 3, 4, and 22. Okay. And then 5 to 5 give us 5 to 5 give us 2. Right. So together these we need to merge these two sets into oh god, I'm out of space here, bruh. Oh. Maybe instead of that we just need to do this. And can we put a line? Can we draw a line? Yeah, right here. What? Connecting what? What is it? Who's sending me message? Okay. So maybe we Stop with the message. Oh, is they shipping something to me in UPS? Fine. Okay, so together this give us 56, 22, and 2. Right. Right. So together these give you that and 56, 22, and 2. Right, so the left subtree is done. People asking me about WeWork. You want to go to WeWork? Okay. Whatever, dude. Be back to this. Can we highlight this with some color or something? Line. Background color. How do you do that? Because looking at this is very tough. Okay. We go on to the right subtree. 6, 7, 6, 7. Sorry, guys. The 1, 2, 3, 4. Wait, 5. 5 is a 0, 1, 2, 3, 4, 5. 6, 7 is 34, 33. 34. What's this? 8, 8 is 22. Right. So 22. Okay. So this give us 34, 33, 22. 34. Right. And 9 to 10 here is what? 0, 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8. 9 here. 9, 10 is 12. And 34. Right. And finally 56. Right. Okay. So then these give us this give us this number 12, 34, 56 is this one. So now we have to merge these two. We see 2, we see 2, we see 2, 34, right? 112, 234. How many? 56. 156 and 33, right? And then we finally merge this, right? So the first thing is when they ask for, let's say 30, what is the question is asking? Let's say they want to look for 22. Let me see. So if they want to look 22 from 0 to 8, right? So first we find 0, right? We look at here and we see, okay, um, how many 0 do you have? 0 to where? 0 to 8, right? So that means we go travel all the way here. We found that we have what? How many? So okay, 0 to 8. So this should cover it. So we found 1, and we search for 8, right? So then it would be this one, right? So yeah, so this would give you 2, another one, 2 here, right? So I guess that's the way we do it. I don't know. Let me see. How do we do a background color here? This. What? Okay, wrong one. Number. No. What about the background color? Oh, background color is here. Put this number. Okay, whatever. Okay, so I'll move this to the side and see if we can implement this. And go back here. Yeah. Okay. So we probably have a class. We call this range node. Okay. And in each of these nodes we have when we want to initialize a node, we want to do a range, right? From oh no, let's do what? FD, right? From to F equal F. So 2 equal 2, right? And then we need to have, so as we can see here in this one, we need to count them, right? So that look like a map instead of a set, right? So let's call this frequency, right? So right, we would, let's remove this. We want to keep the query cache though. So now we want to do, we call this a tree, we call range node. what is it with range we would do is what? Okay, so let's make a function called this. Okay, so let's just pass the entire tree, right, divided by 2. Should we call the function in here itself? Let's do that. Why not? Let's do this. Right. So, oh, we need to have a left subtree and the right subtree, right? So dot left equal to range node. Can we do that? Okay, so this is the passing the 0 to length of the R. Actually, yeah, -1, and we pass the entire array here, right? So then this would become, what's that, 11 plus, okay, so we divide by 2 on the left, okay, so b f 2f plus d divided by 2, and the array also split in half. F 2 inclusive, right? So that means I think f plus d divided by 2 plus 1, right? And right, so the right gonna be f divided 2, this one plus 1 to t, right? T here is inclusive, that means it's the same as that. Okay. So let's just put this left equal f, left from left to equal f, and this one, right? So okay, and we would have here LF L2. The array would start from L2 plus 1, L2 plus 1, so 0 to 5, because array, yeah, right? So let's basically open up Python, right? So let's say we have an array is this, right? This, so array of, that is 0 to 11, right? See, we missed 1, so we had to plus 1, so that's 12. The plus 1 is correct, I think. Okay, So right from right to equal from gonna be f plus 2 divided by, okay, so it would be less 2, right to gonna be 2, right? It's gonna be, what is it, right? RF or T. Okay, so this is RF or T plus 1. So this is the right node. Okay, so we have to stop the recursion. Let me look at. Stop the recursion and initialize the thing here at when the range is equal or the range is one after the others. Okay. Okay, so if self.f equals self.t or self.f plus 1 equal to self.t, right? Then we basically initialize our math, otherwise we continue, right? So okay, so from here we basically say so we do, if this is that, then we initialize our frequency. So this is the base case. So for example 0 1, we would loop from 0 to 1. So for element e in range of from self.f to self.t, right? So this is inclusive, but the range here is plus 1. So if okay, so element gonna be equal to r of I. So if E not in self.frequency equal to 0, right? Otherwise, right, you missed something. Okay, self.frequency of E plus 1, right? So that's the base case that we got that taken care of. We go back up, this taken care of, let's go back up, and after we go back up, we know that in this case, so it go left, go right, and then we have to merge left and right frequency, right? Okay, so we would do for key value in cell.left, right, dot frequency, right? Cell dot frequency if k not in cell dot frequency then self dot frequency, okay, 0, self dot frequency, okay, plus equal to plus equal to v. Similarly for the right, so the right items so basically we should write a function for copy frequency frequent, right, so we do in frequency dot item, right, that. So what we can do now, yeah, copy self, okay, we do self dot copy frequency with self dot left dot frequency, and we do the same for right. Okay, so I think maybe that's it, but we need to test this, right? So okay, so when we query, yes, okay, so if the value is not in the QC, okay, okay, not in cache, then we gotta find, we need to write a function for finding the range, right? So first, let's say they ask for 4. When they ask for 4 in what? In 1 to 2. So 1 to 2. So we will search 2, right? 2 would be so we'll find 1, right? So 1 would be in this range, right? So we want one to 2, we want 4 only, right? How many 4 in that range, right? So 1, so we search for 1, we found maybe we can also expand further, right? Or whatever, right? So 1 would be, should we expand 1 more, right? So this give you 0 and 1, right? So that give you 1, and then so the other one give you 2, right? So this give you 33, right? So let's go deep to that level, right? So that means if you get to that level, right? Right. Okay, so this have one more, right? So when we found one, we found 33, right? And then when we found two, right, it's 4, right? So we found one, right? So basically we need to write a function of finding where should one be, right? Okay, so now let's write a function find let's just call it find for what do we do, value, and okay, so now we want to do is find the left with value, left count, right count. So basically result gonna be, let's just do this, right count equal find in the right with the value, right? So the answer gonna be self.qc left right value equal to LC plus RC, right? That, so all that is left is we need to find the numbers, right? So okay, so first they want to ask from 1 to 2, right? So index, right? So want to search, okay, if index is greater than 0, self.3, oh, we need to do the root here, right? So root here will be self, this would be self.find, would be self.3. So let's call this root then. Okay, so this is root, and this will be self dot yeah, root, right? Okay, so if it is greater than root dot left, oh wait, hold on, greater than left, we go left first, and index less than or equal to self dot root right dot t, right? Then we call find on on the, oh, this is root, so we call self.find on root.left, and the index value else left index greater than or equal to root dot right, right? Left index root dot, oh, this is left. Then basically return here. Cell dot find root dot right index value, right? Otherwise we just return, okay, if values in cell dot no root dot frequency return root dot frequency of that value, otherwise return 0, right? Okay, so now the case is if we found the value, this is for like the middle, the root, let's just go left. Yeah, this should be supplementary. Okay, so for example, if we ask for 4 in 1 to 2, so we found 1, right? We found 1, we give her 33, right? So basically this should split one more, but that's fine. 33. Okay. 33. Okay, so from equal to 2, so how does it work in, so we split one more, right? So be 0 to 1 and 1 to 1, right? And we don't want infinite loop, right? So we don't want infinite loop, right? So this is or cell dot from equal to, so like, yeah, fine. Cell dot from equal to plus 1 equal to 2. So this is correct. So here we say if index equal to cell dot from or index equal to cell dot 2, then we find the value in this, right? And then we want to say right. Okay, so for in the case of this, right, so we go here, we found 1, try and find 1, and we get to here. When we get to here, okay, we found 1 in any of these, and we ask, okay, if the value we're searching for is in that one, right? So if value is in cell in root dot frequency, then return root dot frequency value, right? Otherwise turn 0 because we couldn't find the value. So if we ended here, okay, so first we gotta do it's cell dot left equal none, cell dot right equal none. right? Okay, so we go in here, this one, then there's no left, right? So that means if not root, then also return 0, right? That is what I think it is. Hopefully, run. What? Oh, sure. Where? Self. Object have no attribute. What? Range or node have no attribute range node. What? Yeah. This is range node, right? You can see yourself, right? Python. Oh, it's right there. We do this. Oh, let's print our stuff here. Print fd thing. So 01105, good. Which is this 05 02 01, good. Oh. So the right here had to go on this first one to, yeah. Uh, 01105 02 01 22, good. So what's wrong with it? List index out of range. What? Oh, we should not cut this as well. Just to do this, right? Range query, so 011 05 02 01 22, good. 35 34 55, good. What happened? 611 68 67 88 67 88 9 11 9 10 11 11, good. Okay, so it seems like the tree construction is good. What's happening here? Where are you complaining? Run again. I don't know what line it is. Okay, right here. Oh, okay. Have to be root. Wrong answer. We give 2. Okay, so let's debug stuff. Right, so now we have so let's print some stuff here in find with index. Okay, so let's see this query here. Query, you want query left, right, value. Okay, and then when we want to find, we are in what index? We print root dot oh, root dot from root dot to root dot frequency. Okay, so query 124, right? It go 011 05. So 1205 1233 456 22 2. Good. It should find here, right? So that give you okay, what is the result here? Okay, print result left and right. Zero and 1, right? So 4 give us 1, right? That's good. So basically we found 1 here, but it's not 4, so 0. And then we find what's that? 2, right? We found 2, right? We found 4 1. Good, right? And then we go from 0 to 11, and we found that, okay, 34 is, oh no, what, 33 is 2, right? Oh, I see. So if we found the range already, we got 2 2 here. That is wrong, right? So we have to have a case where if it is exactly the range, okay, we found 0. Okay, we found 0 here, and we found 11, right? If they are both the same node, then we should not count, right? So actually in this find we should return root 0, return root, and that y return root, that right, return root, that root, that. Right. Right, so left and LC, right and LC, result equal to LC plus RC if L is not equal to right, otherwise it's gonna be 1 is fine. Like that. Okay, Hopefully this works. Alright, run. Okay. Submit. Wrong answer. What? 202? Wrong answer too? Let's do some printing. What's wrong here? Two to four. Let's me write the note down. See if my thing is solved. Okay, so you have 2 2 1 2 2 0 1 2 3 4. Good. Okay, so query from 2 to 4 for 1. Right. So we have 0. Okay, so let's do 0 to 4, 0 to 2, and we got 1 here. What? Okay, so let's break them down. 0 to 4, and we have 4 divided by 2 is 2, 0 to 2, and here is going to be 3 to 4, right? Yeah. It's going to be 0 to 1, then 2 2. So 0 1 we would have 2 2 to 0. 2 2 is 1. So this give us 2 2 1. 3 to 4 give us 2 2. This give us 2 2, right? So finally this is 2 2 1 2 2, right? So they asked for 2 to 4, so we find 2. Okay, we found 2, we found, let's give it 1, right? So let's also print the left count here. C or C. What? LC or C. So that's 1 instead of 2. So okay. So now we find 4. Wait, hold on. 0 to 4 we got 2 is 2, 2 4, 1 1. Okay, that's good. 0 to 2 we got 2 is 2, 1 is 1. Okay. So we want to search for 4. They asking for 1. So 1 is in this. Okay. They're asking. So we have this range. They're asking from 2 to 4. So we search for 2. We give 1. And then we search for 4. So 4 is okay in our query here. So we should print the index from to current index that you want going to. This is index. Oh, I don't think index make any differences. Okay, so we wanna go print the. So first we had 0 4. It go into 0 2 for 2. Good. And it found that index equal to this, right? So that give us 1. Good. Right. So index equal to index equal to 2. Yeah, this is the one. So it found it, right? Oh, we can just do this. Right. Left found is right found is right. Okay. So left found 1. Good. So the one in the right here is searching for 4. It found that. Right. We give it another 1. 2 to 4. Which is 2, which is wrong, right? And another. So we need to find 2, which find here, right? So we want to search up until we found single element or one of the left or one of the right equal that, right? Which is in this case that's kinda not correct. So the index we want to find is 4, right? Right. And we need to find either 4 4 or the 2 is 4, right? Right. So maybe we have to change this. If the index equal to, and we want to do root, the left equal root root dot from equal to root dot to equal to index, or index to equal to that, right? So now index equal to root dot 4, all right? Does that fix them magically? No. So left is 1, right is also 1, right? We want to travel down, right? Because we want 4, right? So we look at this and we say, oh, yeah, this is going to be an issue. I'm also hungry. Okay. Maybe I'll come back to this after lunch and then game. We come back to this. Or maybe instead, hold on. Instead of allowing a node with the thing here, we just allow single node here, right? We do this. So in this case that we have here, we extract one further, right? 0 or 1, right? If from equal to 2, right? Then we do this. Let we run this, right? So what do we do happening here? 0 to 4, 0 to 2. So in the case here, we have to find, if we found 2 2, right? So okay, so that means the only case we allow is this, right? What? Okay, 0 4, yeah, we found 2 2, and we turn 1, good. Then 0, result is 1. Okay, so let's try and fix the second case first. And we query, okay, so the 1 is fixed. 0 here is what? Two four one 1 3 1. Okay, so we want to look at 1. So and this give us, we found 1, right? So right here 1 1, we want to find, okay, so that's 0. We want to find 1. What we want to find? From 1 to 3, we want to find 1. So we got 1 1 here. What is, yeah, that's 0, good. And then we want, so on the right for 3 and 3 and 4, right? So that give us 2 2, right? So that's equal 0 0 0. Why? Wait, result is 1. Why? So we want to search from 1 to 3, right? So so 1 would be in this, right? We would take the, so 1 is in 0 and 2, right? So this would give a 2 2 1 instead, right? And 3, we found it in 3 to 4, right? So okay, I am hungry. I will have to continue this after the lunch in the game. So probably I say lunch until 1:30, and then I game for 2 hours something, so like 3 or 4 p.m. But yeah, we'll be back to this. I mean, for the record, I have the solution that I did. Oh wait, hold on. Which I did here, which is fine. Which I just do a index binary search. But since the topic is segment tree, I thought to study segment tree as well. But my implementation has some flaw or something. I will take a look after that. Alright, bye for now.